Hey, 12th graders. We are moving on in our Unit 8 notes. We're going to talk about something called Pearson's product moment correlation coefficient. We typically just call it R or Pearson's coefficient or something like that. This is actually something that is used a lot when talking about statistics. It's a very important idea. It's a very important calculation. It can all be done on your calculator. It's something that if you're going to be doing something statistics oriented in your IA, you're probably going to do Pearson's as a part of your IA and a part of your calculations with statistics. It can be done by hand. So in your IA, you might be like doing it by hand just to be like, hey, I fully understand this material. It's like a nice little props of like, hey, I know how to do this by hand, but we won't learn how to do it by hand here. You would just do that on the IA on your own with me. We'll do it together. But this is something that's important. And the main reason why it's important is because of this. We've talked about correlations. We've talked about how consistent, how strong, weak, or moderate these correlations are. And my question to you is, which one of these graphs right here shows a stronger correlation? I'm so sorry, 12th graders, I tricked you. These are actually the exact same data points, the exact same ones, but you can see that how the scale of your graph can really affect how you see a correlation. So being just presented with a visual of a correlation can be really misleading. Statistics are misused all the time. Well, I wouldn't say misused, I would say used for a purpose all the time. Statistics always have a purpose when they're being presented to you in a news article or in elections or in any sort of presentation of data. There's an agenda there. There always is. And so just be aware that when you see a scatter plot or when you see a graph, knowing what the correlation is right away can be very difficult. So they show the same data. I tricked you. So it's important to have a calculation that tells you what the correlation is and how strong the correlation is without needing to actually look at it and just have this number tell you like, hey, this number signifies that it is a strong, weak, moderate, or no correlation. So that's what R does. That's what Pearson's coefficient does. It tells us the direction of the correlation, so whether it's positive or whether it's negative. It also tells us the strength of the correlation. So strong, moderate, weak, or no. Be careful. This is only used for linear. Pearson's product coefficient is only used for linear correlations, linear relationships. It is a scale. R is a scale from -1 to 1. The negative versus positive aspect tells us the direction, and it's pretty much as straightforward as you can imagine, that in the positive side, it's a positive slope, right? So it goes, from your perspective, it goes up. So for a positive one, the slope goes up like this, and 1 is the strongest possible correlation that you can have. It's a very, very strong, or some might say perfect correlation. Whereas negative is still very, very strong. It's just in the negative direction. So -1, if R equals -1, it is a perfect or near perfect negative correlation. So the slope goes down. 0 is no correlation. So the closer you get to 0, the closer you get to no correlation. So it goes from strong to moderate to weak to no correlation. And then just talking about the directions, whether it's positive or negative. So here, really next to 0 would be a weak positive on this side, versus on the other side of 0, we would have a weak negative correlation. I do want you to keep in mind there are no units. It is just 1, -1, 0, 0.5, -0.2. They are all it's just a number, no units at all, and it's not a percentage. All right, so we are going to go through and assign each of these graphs the Pearson's coefficient here. So just so you start getting a general idea of what's going on. A near perfect positive correlation is going to have a positive number and strong is at 1. So this is actually R equals 1 from problem 1 or from list number 1. This guy is, you can see that it's going in a positive direction. It's fairly moderate, whereas some of these, like this guy is still going in a positive direction, but it's very, very weak. So this I'm going to say is a 0.5. So this is number 3. You need to cross these guys out as we go. Whereas this one, it's still kind of going in a positive direction. It's extremely weak, but it's still positive. So we'll call this a positive 0.2. So this guy's 4. Then this guy is a very moderate positive. It's very obvious that it is positive, and it's fairly well grouped together. So 0.9 would be a good way to describe this, this guy. All right, this is a moderate. Yeah, I would say that this is a moderate negative slope. So I would call this negative 0.5, which is number 7 here. Oh, I know that this is going to be a strong negative. So this would be R equals negative 1. This guy has no correlation. Remember from our 8.1 notes that if it's straight across, no matter what is going on the x-axis, whatever's happening on the y-axis will always be that number, which means there is no correlation. There's nothing that does anything between the two of them. There's no relationship. So this is going to be R equals 0. So we've got still left a strong, fairly strong negative, which would be this guy right here. Notice how it's a lot stronger than this negative over here. So I'm going to call this guy your R equals negative 0.90. It's very strong and going in the negative direction. This guy is still going in a negative direction in a fairly moderate way. So I would have this one be your R equals negative 0.20. And this one is pretty easy to tell, like, look at the extremes here. I could have gone up like this, or I could have gone down like this. There's really no clear one. Whereas like this fairly weak one, we still have like our furthermost outest, our furthest outer points still create this line down. Right, this distance is just a little bit longer than this distance, right? And same with this fairly, very weak one, that this distance is longer than this distance. Notice that these distances are about the same, so there's really no correlation there either. Okay, so hopefully you're starting to get a good idea of what these R's mean. And this is it. This is all that Pearson's coefficient is really about, is just telling us what direction your correlation is going in. Your linear correlation is going in, and then how strong is it. The rest of these notes are pretty long, and the only reason why they're long is because you have to create a scatter diagram for every single one of these. So we're gonna pause for you to make your graphs. But just realize, I know that you guys have struggled in the past with the length of the notes because of when we have to organize data, and this is one of those times where we have to organize data. All right, so we have an experiment. We have a metal bar, it's heated, and its length is measured. The table shows the measurements taken in the experiment. We want to create a scatter diagram. I'm going to create my X and Y axis. On my x-axis, I'm going to put heat, and that's in degrees Celsius. And then on my y-axis, I'm going to go ahead and put length. My handwriting is crazy today. Okay, for heat, we start at 40 and we go to 80. I'm just going to go every other one here and do tens. I've already made these scatter plots, so I know what units to do here. I'm sure, as you've realized, figuring out what units and how to build your graph takes time. I think you know how to do it. but just to help with time management. We're going to skip a little bit of distance here. So I'm going to put this little like cardiogram, like little zigzag here. That just means that like I've sliced off the y-axis and pieced it together in the zone that I want it to be at. Because what I want to do is I want to start at 19.9 and then go to 20 and then 20.1, 20.2. So that's the unit of measurements that I'm going to go up. Okay, and now I would like for you to go ahead and plot each of these points along here. Go ahead and I'll pause the video and you can press play when you're ready to move on.